Hello, everyone. My name is Alexandria. I am a graduate student at the University of New Hampshire, studying for my master's degree in marine biology. So I am a member of the Coastal Restoration and Resiliency Lab under the guidance of Dr. Greg Moore. And I have to admit, I do a lot of my work in Massachusetts, sorry. But I manually sample Necton communities in salt marshes in Massachusetts to see their response to restoration activity. This is an example of sort of that manual effort involving lift nets and a whole lot of people to help me out with that. So with manual sampling, I'm sure many of you are aware, come a lot of limitations. The first being we are restricted by the tide. If the tide is too low, you're going to be trudging your way out of the marsh. And if the tide is too high, your salt marsh pools that I sample are no longer pools and you're going to have to swim your way home. Another extremely limiting factor is the weather. For my first year of sampling, there were numerous heat advisories, which is, a dangerous condition to be out in a salt marsh working in. And then this past summer, so many days of rain that we couldn't go out to sample because the fish just wouldn't want to come out and play with us. And then the last limitation I faced is my sampling gear. Again, I used lift nets for this process and they worked pretty effectively in smaller pools. But in larger pools, it kind of starts to feel like you're not really getting a scope of the full habitat with just these little nets. So we kind of started thinking about an innovative and exciting way that we could remedy these issues while still monitoring the Necton communities. And that's when I was introduced to passive acoustic monitoring. I'm very happy that someone talked about this before me. Makes my job a little bit easier. But PAM is a cost-effective, highly accessible and non-invasive form of habitat monitoring. It allows researchers to track changes in biodiversity and anthropogenic activity in sort of areas of interest without having to be out in the field all the time to get that data themselves. And recently, PAM has been used in tropical wetlands such as the Florida Everglades to track biodiversity and species use of that area in the face of restoration activity. So how I do it, I deploy a variety of PAM devices. So one of each of these devices goes into the pools that I manually sample for a nice comparison. I program these devices so that they record ambient sound continuously, so 24 hours a day, 7 days a week, for the duration of their deployment, which is typically about a month long, and then we pull them up, change out the batteries, drop them back in. Once our data is collected and we're ready to take them out for the field season, I can import the data from these devices, which is an audio file, into the software Raven Pro for further analysis. So some fun stuff that we can get from this data. This is what we call a long-term spectral average, or an LTSA. It will show you the entire duration of your deployment in terms of sound. So on the x-axis, we have date. This is roughly about a month long, starting in August. On the y-axis, we have frequencies starting at 10 kilohertz, and then the intensity of sound, or the loudness of sound, is represented by the color. So a brighter blue in this case represents a louder sound, and then the dark blue represents a quieter sound. And some fun things we can see from this is, for example, I've highlighted rain right here. That was a rainstorm event, and you can see it on this LTSA by sort of the loudness of the sound. And specifically for my work, a really interesting thing that we have found is that the shrimp that I catch in these pools are super noisy, and they only like to make sound during daylight hours. So consistently across the 19 pools that I have acoustic data for, if there are shrimp in there, they make this sort of snapping sound that sounds like bacon frying or Rice Krispies and milk, and it only happens during the hours of like 10 a.m. to 6 p.m. And this sort of banded dial pattern can be shown in an LTSA where we see bands of really bright blue being the shrimp noise during daytime hours, followed by bands of dark blue, which is the shrimp noise during nighttime hours. Just some implications about shrimp in general. The snapping of snapping shrimp and other estuarine shrimp has been shown to be positively correlated with overall habitat health. And for my work down in the salt marshes, we're kind of hoping to see if that trend holds true in our ecosystems. That's what. And I know I can't take questions right now, but happy to answer any at the end. Hang on.